S1 Regression Example 5. In this example, we're returning to the data that we had in the correlation booklet regarding number of newspapers sold and the number of phone calls that generated by a particular company who were advertising. You'll remember that we completed this table in the correlation booklet using these two codings. So that's part A already completed. Part B asks us to calculate the regression line of y on x. Now that actually means that it's a coded regression line. Now unlike with a correlation coefficient, we do have to decode it at the end. So we start off as usual by working out b, which is sxy over sxx. Now, if you look back at the previous work that we did in the correlation booklet, we've already worked these out and they're given in the question. So we've got 5955.83 and we're going to divide that by 1462.83. And if we work that out for B, we get 4.0714 and so on. A is y bar minus bx bar. So y bar is 151 over 6. And then we're going to subtract b. So again, keep this number in your calculator. Multiplied by x bar, that's minus 5 that they add up to, divided by 6. Make sure you do this bit really carefully because we've got a negative here and we're subtracting it, so it will become a plus. And when you do all that for A, you should get 28.5447. Again, keep that number in your calculator as well. So the regression line is A plus BX. So that's 28.5 if we round into 3SF plus 4.07 multiplied by x. And that's the regression line of y on x. We're now asked to work out the regression line of R on P. We're not going to start again using all this data. All we're going to do is change the variables. So where we've got an x, we're going to substitute this expression at the top, and where we've got the y, we're going to substitute this expression r minus 500. So for part C, we've got y equals 20. Now, because we are going to be doing some other calculations here, I would recommend that you use the full data that you had earlier. So 28.544 and so on. And later on, I'll try to say it in full first, and then we'll actually have a look at what we're going to do. So keep the full value that you've got stored in your calculator up here. So that's the current regression line. Where the y is, we're going to substitute r minus 500. We've got 28.544 and 4.0714 and the rest of it multiplied by x. Now x is p minus 30,000 divided by 500. Okay, so that's 500 there on the bottom. What we need to do now is rearrange this, expand the brackets and so on, so that we get r equals a number plus a coefficient multiplied by p. So we really want r equals something plus a number of p. That's the format that we want it in. So we'll bring this 500 over onto this side. We'll be multiplying out these brackets. And when you go through that process, you should hopefully get, rounded to 3SF, 284 plus 0.00814 multiplied by p. Now obviously, depending on how accurate the numbers are that you've saved in your calculator, we may get slightly different answers here. But as long as you've made sure that you've expanded the brackets and tried to keep it as accurate as you can, there's sometimes a little bit of leeway on the exam questions, but you do need to make sure you're as accurate as possible. Part D is now asking us to interpret the coefficients of the regression line of R on P. So we worked out a regression line of Y on X, that was coded. We've decoded it by substituting back in the two expressions, and now we've got to interpret them. Now, if you remember, R was the number of phone calls, and if we were plotting it on a diagram, that would go up the side. And P was the number of papers that we'd sold. We've worked out this regression line. 284 is the y-intercept, or in this case, the r-intercept. And this is the gradient. It's really, really shallow gradient. Very, very small number. So what does 284 actually mean? 284 is the y-intercept. So 284 means, well, let's have a look. This is the point at which P is 0. P is the number of papers sold. So what that tells us is that if we sold no newspapers, this company would still get 284 phone calls. That might be through other sources of advertising or through regular customers. So 284 means if no papers are sold, no papers are sold, the company will get 284 calls. What does 0.00814 mean? Well, think about gradient. The gradient of a line means for every one along, how far up do you go? So in this case, for every extra one on the horizontal axis, what's going to happen vertically? Okay. So what this means is for every extra one horizontally, so that's for every extra newspaper sold, because the horizontal axis goes up in ones, for every extra newspaper sold, the company will get an additional, because it's going up by this amount, 0.00814 phone calls. You might say that's not very much. For every extra newspaper, we get a tiny fraction of an extra phone call. But think about it in terms of scaling it up. If we multiply by 1,000, that means for every 1,000 newspapers sold, you get another 8 phone calls. And if there's a fairly big circulation on the newspaper, which there is for most newspapers, that's a pretty good return on advertising.